Okay, the next topic is called rationalization. So, a number such as 4 divided by 1 plus square root of 3 or 34 divided by square root of 3 need to be rationalized, meaning the bottom number, the denominator, must be an integer. So, for rationalization of a number, which has the denominator square root of a, you'll need to multiply the fraction by square root of a divided by square root of a, meaning in the sense this won't really change because this would equate to 1. So multiplying something by 1 does not change the value. So yeah, that's the whole theory behind this. And then for any fraction in the form c by a plus square root of b, you'll need to multiply the fraction by a minus square root of b divided by a minus square root of b. This would also equate to 1. So that's fine. So yeah. So here what we're trying to do is write this in the form a squared minus b squared, because we know that a plus will take x plus y into x minus y is by x squared minus y squared. So we're using the same thing here. That's what we're trying to do. So now let's solve a few examples. So this is our first problem. So this would be 5 divided by 3 minus square root of 2. We'd have to multiply this by 3 plus square root of 2 divided by 3 plus square root of 2. So this would be in the form a minus b into a plus b. That would equate to a squared minus b squared. So now what we can do is 5 into 3 plus square root of 2 divided by 3 squared minus square root of 2 squared. Now we can simplify this. We multiply 5 into 3, so that's 15, plus 5 into square root of 2 divided by 3 squared is 9 minus square root of 2 whole squared we just saw is 2. So this would be 15 plus 5 root 2 divided by 7. So we could leave it like this. This is our final answer. So we'd use the same procedure. 2 divided by 3 minus square root of 2 into 3 plus square root of 2 divided by 3 plus square root of 2 equals 6 plus 2 square root of 2 divided by 3 squared is 9, and then this squared would be 2, so that would be 6 plus 2 square root of 2 divided by 7. So that's our answer. You can go ahead and solve these two. I will also solve them now. Okay, so now I'll solve these two problems also. So what we'll have to do is rationalize the denominator. So this would equal square root of 3 plus 2 divided by square root of 3 minus 1. Now we can write this as square root of 3 plus 1 divided by square root of 3 plus 1. So this would be it would be this divided by square root of 3 whole squared plus minus 1 squared. This would equal square root of 3 into square root of 3 is 3 plus square root of 3 plus 2 square root of 3, because this multiplied by this multiplied by this multiplied by this, and this by this. That's 2 divided by square root of 3 whole squared would be 3 minus 1. We could add like terms, so that would be 5 plus 3 square root of 3 divided by 2. Okay, so now let's solve this. Square root of 7 minus 7 divided by square root of 10 plus 4 multiplied by square root of 10 minus 4 divided by square root of 10 minus 4. This would be square root of 10 minus 7 into square root of 10 minus 4. divided by square root of 10 whole squared would be 10 minus 16. This would be 10 minus 4 root 10 minus 7 root 10 plus 28 divided by minus 6. It would be 38 minus 11 root 10 divided by minus 6. This is our final answer. So now let's move on to the next topic in this chapter. So here I've written down a few things. So 7 to the power of 4, this is equivalent to 7 into 7 into 7 into 7 into 7. So 7 multiplied by itself 4 times. So that's what this means. And then 3 to the power of 5 is 3 multiplied by itself 5 times. So 3 into 3. 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3. And then 5 to the power of 3 is 5 multiplied by itself 3 times. That's the meaning of this. And that would be 5 multiplied by 5 multiplied by 5. And now let's look at this one. So minus 1 to the power of 1 is minus 1. But then minus 1 to the power of 2 is minus 1 into minus 1 equals 1. And then minus 1 whole to the power of 3 would be minus 1 into minus 1 into minus 1. That would be minus 1. And then minus 1 to the power of 4 would be minus 1 into minus 1 into minus 1 into minus 1. That would be 1, because a negative number multiplied by a negative number would be positive, and a negative number multiplied by a negative number would be positive. So a positive into a positive would be a positive number. So this is what we have derived. So we know that these are the concluding things. So a negative base raised to an odd index, this is the index, to the power of would be the index. So a negative base raised to an odd index is negative, and a negative base raised to an even index is positive. So negative minus 1 is a negative number. When it's raised to an even index, it would be positive. I'd also like to clarify one more thing. So negative 1 whole squared is not equivalent to minus 1 whole squared. This is not equivalent. So minus 1 whole squared would be minus 1 into minus 1. That would be 1, whereas minus 1, this would be minus 1. Let's also take another example. Let's take minus 8 whole squared. This would be negative 8 into negative 8. That would be 64. Whereas a negative of negative 8 squared would be negative of 8 into 8. That would be negative 64. So these two are two different things. So the next part of this chapter is called as index laws. So a to the power of m multiplied by a to the power of n equals a to the power of m plus n. So this explains this. To multiply numbers with the same base, keep the base same and add the powers. So I'll just show you an example. So for example, 5 to the power of 4 multiplied by 5 to the power of 3. We know that this is 5 into 5 into 5 into 5 into 5 multiplied by 5 multiplied by 5. So there is 1, 2, 3, 4, 5, 6, 7. So that would be 5 to the power of 7. This is equivalent to 5 to the power of 4 plus 3, that is 5 to the power of 7. So therefore this is the law. So the next part states that a to the power of m divided by a to the power of n equals a to the power of m minus n. So to divide numbers with the same base, you'll have to keep the base and subtract the powers. It's very similar to the old one, the previous one. And the next one states that a to the power of m to the power of n equals a to the power of m to the into n. Just you'll have to multiply. So when raising a power to a power, keep the base same and multiply the indices. And then in brackets ab to the power of n. So you'll have to distribute the power of n. So it will be a to the power of n into b to the power of n. So the power of a product is the product of the powers. And then a divided by b to the power of n, it's very similar. It would be a to the power of n divided by b to the power of n. So the power of the quotient is the quotient of the power. And then a to the power of 0 equals 1. And a must not be equal to 0. So any non-zero number raised to the power of 0 is 1. And a to the power of minus 1 equals 1 divided by a to the power of n, and 1 divided by a to the power of minus n equals a to the power of n. And a particular case you'll have to remember is a to the power of minus 1 equals 1 by a, and a must not equal 0. Yeah, so this is all. And now let's move on to the next one. And so we use the index laws that we used previously can be applied to this new one, and it can be written as fractions. So the notation a to the power of n, as we already know, is defined as a multiplied by itself n times. So square root of a will be represented by a to the power of 1 by 2, and cube root, this is the symbol for cube root. So cube root of a equals a to the power of 1 by 3. Therefore, n root of a would be a to the power of 1 by n. So this is how we derive it, this one. So it would be, this one would be a to the power of m divided by n. So now let's solve a few of these examples. Okay, let's start with the first one. So we know that 3 is 3 to the power of 1, and square root of 3 is this. And now we already know this rule, so it would be 3 to the power of 1 plus 1 divided by 2. That would be 3 to the power of 1 by 5. 1.5, I mean. So that is 3 by 2. This is our final answer. And now let's move on to the next one. 1 divided by cube root of 32. So 32 can be written as 2 to the power of 5. So it would be cube root of 2 to the power of 5. As we know, this can be written as this. And now we can use another law where we know that 1 divided by a to the power of n equals a to the power of negative n. So it would be 2 to the power of negative 5 by 3. Okay, so the next one, it's 1 divided by this one. 27 can be written as 3 to the power of 3, meaning 3 cubed. So this would be, and then it would be 1 divided by 3 to the power of 3 divided by 4. And then this could be written as 3 to the power of negative 3 divided by 4. So that's our answer. And then let's solve these two. Okay, so 16 can be written as 2 to the power of 4. So that would be cube root of 2 to the power of 4. That would be 1 divided by 2 to the power of 4 divided by 3. That would be 2 to the power of negative 4 divided by 3. The next one, this would be very simple. It's 2 to the power of 1 by 5, and then 2 to the power of 1 by minus 1 by 5.